Welcome back, guys. Today is Radical Equations Day 1, week number 3. I'm going to go over the notes here. Please check these out first, and then try the problems, and if you still need some help, you can just join one of the Zoom chats. Alright, so number 1, what we want to do when we solve a radical equation is to get rid of all radicals. So, the easiest way to do that is to raise each one to that power. So that will be, since it's a square root, a power of 2. And what that does is it basically negates or knocks out the radicals, the square roots. So now we're left with n minus 4 equals 20 minus n. So at this point we're just solving for n. It's just a basic equation. So I'm going to add n to both sides. That's going to give me 2n minus 4 equals 20. And I'm going to keep solving for n. So I'm going to add 4 over, add 4 over. I'm going to get 2n equals 24. Divide by 2, and n equals 12. Alright, what they mean by extraneous solutions, which is right up here, is sometimes when you solve these problems, you create answers that don't actually work when you go back and check them. So this will be me checking it. I won't do this on every problem, but this is how you would check it. You're going to have the square root of n minus 4 equals the square root of 20 minus n. So we're going to replace the n with 12. So it would be the square root of 12 minus 4 equals the square root of 20 minus 12. So that would be the square root of 8 equals the square root of 8. So we know that's the same thing, so 12 does in fact work. Alright, so we're going to try the second one, same technique. Alright, as you can see, this answer is going to be 6. So let's see if we can figure out how to get there. Alright, we got to get rid of the square roots, so we're going to square both sides. Again, that's going to knock out our square roots, leaving us with just a basic equation again. We're going to subtract our 2k to the other side. I'm going to get negative 6 equals negative 1k. And I can't have a negative 1 there. I'm going to divide it out. And 6 equals k. Again, when you would go to check this answer, you would take that solution, that 6, and you would substitute it back into both of those locations. Alright, some mental math. 2 times 6 would be 12. 12 minus 6 would be 6, which does in fact equal 6. And so that answer checks out as well. Alright, let's try number 3 and number 4. As you can see, they're very similar problems. I'm going to zoom in on number 3. Easiest way to do this, again, is to get rid of the square roots. So we're going to square both sides. Alright, when we square both sides, we get rid of the roots. So it's 2x minus 7 equals 5 minus x. Then you just pick which x you want to move first. I'm going to opt to add this x. Solve for the x's first. 3x minus 7 equals 5. I'm going to add 7 to both sides. 3x equals 12. And then, of course, my last step will be to divide out the 3. Or you could do that in your head. X equals 4. Again, when you would go to check it, you're simply replacing what's in there with that value. Alright, so that 4 will go here for x, and we'll go here for x. So that's going to be 2 times 4, which will be 8 minus 7. And the second one will be 5 minus 4. And as you can see, you're going to get the square root of 1 equals the square root of 1. And that is true. So we know that that is not an extraneous solution. That is, in fact, the answer. Okay, number 4. Again, you want to get rid of the square roots. So we're going to square both sides. All right, these problems are pretty straightforward once you get rid of that step. 3b minus 29 equals 11 minus b. again, you're solving for the variable, so in this case it's b. So I'm going to do the opposite. Since I'm moving it to the opposite side, I'm going to add b. So 4b minus 29, because remember that's like a 1b there, equals 11. I want to isolate the b, so I'm going to add the 29 over. 4b equals 40. And then, of course, your last step will be divide by 4, so b equals 10. Again, I went over how to check it. You would just take that 10 and substitute it back in here and here. So one equation will be 3 times 10 minus 29, and the other equation will be 11 minus 10. Both of them are under roots, square roots. So that would be 30 minus 29, which is 1. And that's going to be 11 minus 10, which is also 1. So you can see here that it also works for that one. Okay? Alright, the reason why we check for extraneous solutions is whenever we start raising powers to different sides that didn't already have them, sometimes we create extra answers. Now, number 5, as you can see here, actually has 2 answers. So this is going to be a little unique. Okay, the biggest thing here is you want to isolate any square roots by themselves. So since this one was already by itself, what we're going to do is we're going to go ahead and raise it to the second power to get rid of the square root, just like we did on the other ones. But on the left side, it doesn't actually have a square root. So you have to treat that like it has parentheses. So now when you square that, you've created a FOIL problem. It's going to be v minus 7 times v minus 7. That's what that little 2 means. This is a type of problem that sometimes has an extraneous solution. But the fact that the answer has 2 of them more than likely means that we don't have an extraneous solution. But this is the type of problem you would see that in. Alright, you have to use FOIL. So v times v, v squared, v times negative 7, negative 7v, negative 7 times v, negative 7v, and negative 7 times negative 7, 49. And we still have 2v minus 14 on this side. Okay, so I'm going to go ahead and simplify the left side. These two are like terms, so that's negative 14v. Alright, now I have all of these variables. In this particular case, there's no way to get rid of v squared, so I'm going to have to pull everything to one side. So I'm going to have to move my 2v by subtracting it over. Okay, and then I'm going to have v squared minus 16v plus 49 equals negative 14. Then I have to pull the 14 over, so I'm going to have to add it. It's actually a negative, so I'm going to have to do a positive and add it. Alright, v squared minus 16v plus, now I have to add the 49 and the 14 together. Alright, 49 plus 14 would be 63. At this point, I've got v squared minus 16v plus 63. There's a lot more work on this problem than the previous one. At this point, you're going to have to factor to get your 2 solutions. What variable times itself will give you v squared? That'll be v times v. Factors of 63, now the ones I can think of are 1 and 63 and 9 and 7. I have to use 9 and 7 because 9 plus 7 is 16. Now 16 right there is negative, so that means they're both going to be negative. Now if you'll look back at the answer is 9 and 7. So to get that answer, you have to take both of these that are in the parentheses and set them equal to 0. So that means you're going to add 9 and add 7, and you're going to get v equals 9 and v equals 7. So since both of these are listed as answers, what that means is if I take both 9 and 7 separately and substitute them back in, they both work. And we've practiced how to substitute already on the previous problem. So all you would have to do is substitute back in the 9 and the 7, respectively, into the v values, and they both would check out. Okay? Alright, number 6.